let's talk about the dividing out technique and when you would need it. Suppose you put this function right here in your calculator, x squared plus x minus 6 divided by x plus 3. If you look carefully, your graphing calculator will give you this little glitch. This is an incorrect graph. The function is not defined at x equals negative 3. How do I know this? Because when I put in negative 3 in, when I do a direct substitution, this tells me I've got what? Negative 3 squared plus negative 3 minus 6 divided by negative 3 plus 3. So this is 9 minus 9 divided by 0. So it's 0 over 0. Now, if it was just a number over 0, then I would just simply say it doesn't exist. But because I have 0 over 0, and I cannot do that, all right, that tells me I may be able to do something to get an answer. And we're going to use dividing out when we have polynomials. So let's just kind of jump into one. We've done this. We found that this is equal to 0 over 0, and we can't do that. All right. The second thing we've checked is I have a polynomial that I can factor. Okay, I see that I have a factorable polynomial in both the numerator and denominator. And hint, we want to get rid of x plus 3. This is when it's very straightforward and very easy, but sometimes it's going to be kind of hard to figure out what you need to factor. So I'm going to check down here when x is negative 3, this is 0, so I will use x plus 3 as a factor. Now I'm going to rewrite this by factoring. Now x squared plus x minus 6 factors very nicely into x plus 3 times x minus 2. Now you can do your factoring any way you like. All right. Now I can see that these two terms are going to cancel. And so I can rewrite this as a limit as x approaches 3 of x minus 2, which is 3 minus 2, or 1. So that would be very useful if I had done that correctly. What did I do wrong, folks? I plugged in the wrong value. That is correct, but that's not the one we're looking for. We're looking for the limit as x goes to negative 3 of x minus 2, which is negative 3 minus 2, which is negative 5. Okay, let's just point out really quickly, number one mistake is often using the wrong c. Don't make up your own, use the one in the problem.